recording. Go on.
Okay. Anyway, it's just like people force like try it to make something really bad. Like it's totally out of this world. Anyway, we need to change the AST for what we need to change. I don't even remember.
We need to make it because I think that the AST that the evaluator is using is not considering that we have types like in the labels, and we need that to happen now.
Yeah.
But before that, I want to test. Uh, wait. Oh no, we added types to the parser. We can't test. We need to go straight up to this. Okay,
Check if you have the LSP.
I don't. I received a warning down
Just
here.
type LSP. You just need to install that. Erlang LS. It works much better on Emacs, by the way.
Oh yeah?
Yeah.
How can I? Do I need to make anything fancy to install
Just
that?
go to your niche shell.
Okay, let me pause. Pause. Okay, unpaused.
Type IO
IO.
and column. There it is. So hover over something and just like wait. See if you have the docs. Like
One.
lists, whatever.
Oh.
Lists. Just hover, wait. Yeah, just don't move. Yes, there it is. So it shows the stuff, but some of them have the documentation. I don't know why it's not. What are those lines? Okay, there it is. You see?
Mhm.
So you can scroll that and then you
That's
have your
much better.
yeah.
Okay.
Don't need to keep looking at that garbage.
Okay. So I think this should be not. This shouldn't be hard, though. I'm fairly certain this shouldn't be hard.
Like if it's just changing, it's just adapting the thing. But I don't remember where the stuff is. By the way, the types.
I remember. Okay. So the first one
Oh, so
is.
the typer is already right. That you
Yeah,
saying?
we are assuming it is. We can test it for a fact.
Okay.
Well, wait. We can. We can test. Okay. So let's go to Spoon. And we're gonna read a file. Instead of calling the evaluator, we're gonna call the typer. And then we just type check like this. And you pass the ST. And then this should type check. And that
Okay.
should be it. REPL not found.
Oh, RAPL is for only LFA.
Uh,
So it's shell.
shell goat.
Quack, quack, quack,
No.
quack.
But this was also happening last time. That's fine.
Okay.
Spoon. This.
So
Uh,
knife.
we have a main function. Main.
Okay, who cares?
Is this the one that we need the dots at the end? No.
You always need a dot and then in Erlang.
Okay. And then we put examples, simple.
Isn't it a string?
I guess so.
Check the name if it's alright. Spoon May
Oh,
Arg. Yeah, not exporting. Export, right? Oh no, you already exported. Oh, the typer. Okay. Oh, it's so cringe.
it's fine.
You can recompile from within the thing.
How?
Just see,
C.
open close parentheses, and then a string with the name of the thing you want to recompile. So like spoon dot. Oh, it needs to be an URL file. That's why. No, like just the name literally of the URL. Shit, we want to recompile.
Just the name can.
Yeah, no
Okay.
such file or directory spoon URL. It will look for where is that spoon.url,
Mm-hmm.
which is inside src.
Oh, SRC.
So I think it's src slash.
Okay.
Yeah, see?
Okay. Spoon. Main.
Exception, okay.
I'm
In
confused.
functions on main, line 14.
Am I exporting?
Invalid
I am.
character encountered. What?
Oh, this is the parser.
Oh, okay.
This is the parser. I will fix that eventually, by the way.
Oh, why did you? Oh man, why did you come up with this?
We're missing types.
Oh yeah, we don't have inference. That's
Not
cringe.
yet.
Not yet. We're not gonna have on this, so I'm sorry. You can do it alone.
No, no, no.
I
We
mean,
will have. Not in this version of the thing, but we will have.
okay, yeah. In Silverware Plus, I accept that. Wouldn't type check with arguments p and
Yeah,
dude, that's
they.
so useful. Oh, we are formatting exception. That's why it doesn't show because that's not a format string.
Yeah, I need to. That's that again. This is the type. Oh no, this is the evaluator.
We changed the. Is this the evaluator? Are you sure?
No, no, this is the typer. Sorry, this is
Yeah,
the
this is the
spoon.
typer.
I was about. I
Yeah,
wanted
but
to say that this. Oh, this is
yeah.
the knife parser breaking again. No, this is spoon breaking this time.
Yes, but I think it's breaking.
Couldn't
Couldn't
type
type
check
check.
application with arguments. Where that is
We
happening?
changed. What have we changed on the AST? You remember?
Well, in my mind, the AST that the knife is producing is the same that the typer expects. Maybe I'm wrong.
Well,
Oh,
apparently
here it
you are.
is. No, it's not this. Where is that error message? Okay, oh, here. Couldn't type check application with arguments. Is this an application?
So that is. Yes, it is.
It is not.
It
It
is.
is just a condition.
No, no. Second line.
This is an application.
Yes. So that's where it's failing.
Don't we need the extra things?
No, that's already an extra parenthesis there.
Oh yeah, that's true. Okay, so the application is the one breaking. So let's.
Extra things. Be respectful towards them.
Now you want respect. Okay, it is still breaking, but it is the same error message. Okay, so couldn't type check application with arguments, right? So it's trying to type check that. I'm fairly certain this isn't right.
Okay. What?
We are calling typer type check application,
Uh huh.
and then we are and then we have the this
Let me
literal one
see.
two literal one and a plus. Does that make sense?
Yes,
Yeah,
that's right.
this is it here. So we. Oh wait, the typer is complaining that this is wrong.
Oh wait, but that.
That is wrong indeed.
Wait, what
Thanks.
is wrong?
This is not an integer.
It is.
No, it's not. This
It is
is
true.
a native function.
Oh, okay, but we don't have. But wait, the typer should understand that the application of that is two. Oh, but the native function, I think, doesn't have parameters.
Let's do something a little bit less
Yeah,
ambitious.
I think I know why. Because a native function does not have labels. Oh, I don't want to fix that.
No function called. Interesting. Very,
No function
very
clause
interesting.
matching typer. Blah 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 blah. And then it's an application of multiplication.
And variable x and variable y.
What?
Type
No
check
function
variable.
clause.
Type check variable. It's complaining there. Okay, let's go there. Type check variable. You pick the name
And
and you check the environment and you try to find it.
what is the? Can you go back? Yeah. So so x and y, they're both integers. You see there,
Mm-hmm.
and the multiplication is just there. It's the environment as well. I'll bring up.
Um.
No function clause matching. What the heck?
Okay, so let's add printing here.
Uh,
So
Just
F
debugging.
right, P.
This debugging is just cringe.
Environment and name. Wait, where? What? Didn't save it? I save it. Is this correct?
This is lying to you, man.
It is lying, you say.
I can't think of anything, so I'm just saying it's lying. Dude, what the heck?
Yeah, it is not printing at all, and I don't know why. Is this how you print? I already forgot. Yeah, it is. You have this and that. Yeah, I'm completely not aware. Wait, this is trying to find this entire thing in here?
I don't know, man.
That would be very wrong.
Because everything is in there, so
No, it's not.
it's
We don't have a map of all of this to something else. We have
what do you
only
mean?
for this guy.
No. I'm not talking about everything. It doesn't make sense to ask for anything. For everything, I mean.
I know, but okay, we are being too ambitious again. So
No, but wait, dude. No, go back there, please. What? Where is that thing breaking?
it's breaking in the type check variable, which is this. But I'm not. It's not printing for me stuff.
On the type check variable. Are you sure? Look at the line there. Isn't that just a stack trace?
No, here exception new. No function clause matching. Type check variable. Oh, it's because we are assuming it's gonna
Just
be a
a
variable
sec.
in here.
Yeah, but
Mute your mic, man.
okay. Well, what did you say?
No, if you are talking to someone, remember to mute your mic.
You can do like uh, you can do like equals what the fuck, like variable name and then equals on the other function. You didn't need to do that.
Yeah, but this is also gonna work.
Not really.
It will because this will not is not pattern matching in here, but it will here.
No, it will pattern match. Oh, okay. It's not entering there, right?
Yeah, it's
That's
not
fine.
entering there. That's why it's complaining. Examples, simple. But am I crazy? Oh, am I? I am crazy.
Probably. I don't know if it's because of that, but
Yeah,
probably.
that's exactly it. So we are passing this, man, to type check variable. What the? That is wrong AF.
Yes.
Uh,
I think I just damaged the board of my CD drive, but who cares? If it doesn't work, I'm just throwing this on the garbage anyway.
let's
You
read
should watch
this now.
the documentary on consumism in America.
Is this correct?
Wait.
Look at the screen.
Wait a second. Oh, finished. Okay, my CD drive is back to life. I never mind this garbage again. Okay, so what did you do?
This is the thing that this is the ST that it is being the parser is providing for us.
It's an application of an abstraction that is not variadic, takes two things, and then inside it has an application of. No, they're arguments, right? They are an application. No, inside the thing, it's an application of multiplication over x and y with the arguments. Yeah, that's completely right.
No, I don't think so.
That is that's
Uh, let me. Oops. Let me. How we were doing this before? Here. Oh, it's because in our test we never tested doing an operation inside. Holy crap! That's why I don't think type check application is expecting to be able to do that. That's why it's wrong. You see here, we are always saying that the body is a variable. We never consider it to be. We never consider it to be something else, man. Okay, so this is right. So this is an application, and then what is the application what you have? An abstraction, which in this case is a variable. No, but this is not a variable, right? Magenta? Magenta. Okay. Magenta, you're there? I can't hear you, man. Am I the problem? Maybe I am the problem. Does this make sense, man?
go back there.
Because we have an application
Yes, it
and the
does. A
abstraction is a
native function
variable.
is a variable. Yeah, that's right.
Okay, so I think this needs to mean that type check environment, this is wrong.
Let me see.
This is the
Type
function that
check
is wrong.
environment that takes an application, abstraction, which is just a name for like some the abstraction part and the arguments.
Yeah.
So go there to
Yeah,
the
so the
application.
application is because the outer one is an application. So it's gonna
Yeah.
go here, right? Then, wait, does that make sense? You see here, man, we are trying to pattern match just a function. That doesn't make sense, right? Because this is not a function. This isn't a well, this is a function, but it is an abstraction, right?
An abstraction gets typed before, and that needs to
Oh,
deal with the
here.
function.
Okay, type check
Yeah.
abstraction needs to transform this. Okay, so let's go here. So what was this expecting? This is expecting to have the variadic info. No, not here. Sorry, here. Yeah, abstraction. So we're gonna pattern match this guy. The parameters, this, and then we have the body, which is in our case is an application. Yeah.
Oh, okay. I think I know what might be the issue. Go to the abstraction.
In the abstraction, we have exactly that
What is
body.
the return type?
The return type is evaluating the body passing
Which
the
is
new
a list.
environment,
Which is a list.
which is a list.
So that's wrong.
Oh, it's because of the internal prog n.
Yes.
So we need to
Last.
for no the last. Yeah, you're correct. Good job, Mageta.
Good
Maybe
job. You
maybe
spoke
if I
like I'm some. You spoke like I'm a dog or something. Man. Dude, why
no.
the parentheses, man?
Oh yeah.
You're going insane, man.
Maybe if I encourage you a little more, you're gonna be happier, man. Because right now you just complain, complain, complain.
I just want to finish. I just want to finish.
No, you not just want to finish. You
I
don't
just want
care
to bury.
finishing.
Yeah, that's true. I don't want to finish it.
You
I
don't
just
even care if it's finishing in a garbage way anymore.
yes, I don't. I want to literally force push. I think removing this REPL. That's what I want to do right
No,
now.
the REPL will maintain.
Okay, now it's different. Couldn't type check arguments. Blah 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 blah.
Oh, okay. Something that I need to do now that we have that error message is to remove the type check variable pattern matching everything. Probably maybe this is changing the things. And I'm still forgetting that I can just recompile.
Yeah, because you lose the commands that way.
Yeah, that's really annoying.
And the CD is stuck again. Kill me.
Couldn't type check application with arguments. Couldn't type check application with arguments. Who is saying that?
Can can you print before, like right before it's the last one? Yeah.
Couldn't type check.
Print the arguments and the abstraction.
No, we can just. Oh.
No, that doesn't mean shit, man.
No, it means because the error message is right below. We're gonna see exactly what this produces, the type check environment. I'm guessing it needs to have something wrong, fundamentally wrong. What is the command?
What? The
To
command for?
redo stuff. Oh, C source spoon.
Yeah.
Source spoon. What? That doesn't make any sense. Couldn't type check application with arguments in abstraction this. Yeah, so it's not printing. Why?
Yeah, the print the arguments and the conditions. That's more useful.
The arguments in abstraction, you mean?
Yeah, which is down there.
I don't know if it's more useful, but
It is.
oh, I can print in here. Arguments. Man,
So it is the same thing.
I'm not believing it.
Yeah. Oh, but wait, you're not compiling again the correct file. You're compiling the spoon.
Oh, that's why it makes a lot of sense now. Simple. Now we are talking. Okay.
Hmm.
Um,
Oh, it is right.
it is arguments
Yeah.
x and y, and the abstraction is times. What is the return of that then?
But wait, dude, let me read first. So it is failing because it could not type check what? The
This.
abstraction.
Yeah. So the return of the
Makes sense
abstraction is wrong.
because no, dude, no, man, it makes total sense. How
Why?
are you going to type check a native function? Like,
Does
what
that
is the
matter?
type?
Let me check.
It does because what is the type of a native function? Like, look at the terminal again. Guys, scroll up. Look at somewhere that had the environment. Like, it's up there. Yeah, it's there, for example. Like, look at the x and y down there.
X
You
and
see,
Y down
you
there.
have x that maps to an integer. No. On the map,
Oh, X that maps to an
maps
integer
to an
and Y
integer
that maps
and
to
blah,
this.
blah. The others are mapping to a
Oh.
native func. I think that's the part that is wrong.
Okay.
So we either forgot or we are not mapping to a function, something like this.
No, I think we forgot that, which
Because I
is.
don't remember doing a native function
No,
typing.
no, we didn't make it. We didn't make it. But I think there is a fast way to do that. Let me just check just for a sec. Let me think a little bit. Where was I printing that? I was printing that in here. Right.
I'm very tempted to just introduce a type called any.
You want to add new?
No, it's not null. It's not null. It's any.
Yeah, but new can be any.
Shh. Shh. No. Any is different than null because null is having nothing. Null is not a value. Any represents a value that you don't know anything. They're different.
Um,
No value is a contradiction in terms. That's a good article. Because think about this, man. How are you gonna type a native function?
It's easy. We just add a list in the tuple.
Yeah, in the prelude, making a whole other loading garbage on the environment for each function. Like,
Yeah, but
dude,
yeah, it's basically a poor man's version of the type classes. So.
it, just
Where are we trying to find that, by the way?
nowhere.
Nowhere. Nowhere. You say. You said no. Oh, it's in here.
Because look at the variety, look at the abstraction, how we're matching. That's only for an abstraction, a conventional one. We don't have the variadic info, we don't have labels, we don't have that for the native function. It's totally different.
Yeah, no, that is correct. But I'm
Let's
thinking.
make another pattern matching, it's easier.
Yeah, that's what
Just
I'm thinking. But
like
where are we gonna pattern match? That's what I want to know.
oh, before this abstraction, do a type check abstraction with environment and look at the type again. I don't remember what that was. Native func and then the lambda.
No, no, no. But the native func is being. We are trying to find the type for that in this call because in this case the plus is the return
No,
type.
but man, you didn't get me. Like it will not even match there. Look at line 7.
But I think it should.
It shouldn't. It should in another function. Look at line 7.
No, no. Wait, I'm confused. Wait, so just a sec. Let's do what you say, and I will understand later.
No, first understand what I'm saying. Like look at lines 2 now down.
No, I see that we are expecting on line 2 down, we are expecting to have variadic info and labels
Yes,
and a body.
which is not the case for a lambda. So how are you gonna match anything if you can't even get there?
Oh, I see. So,
So native func, and then you can ignore the lambda because who cares?
yeah, but I want to, I'm gonna put type just for now because we're gonna
Oh,
add
but
that
it
in the
don't.
prelude.
But we don't have. Okay, we are gonna have to add that because
Yeah,
you don't.
and then the body, right?
Don't you need the input and output, like type input, type output?
Uh, input types, output type. Um, okay, so let's not make it overloaded. Or you can only accept one type. Um,
Oh, I don't see why that would be hard.
because the output type would also have to change according to the inputs, right?
But you're not checking the inputs.
No, but
You're
we
just
will.
checking. No, yes, but in that case, it's the same thing as an abstraction.
Okay. So
Output, I think though that's hard.
that's what I mean
And,
because it
and actually,
depends.
output. No, 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 no. Wait, an output you cannot have multiple types.
Can't I have? Oh, it needs to be the same as the inputs, right?
No, no. I'm saying the output needs to be essentially one type. You can't output like two different types. Like
Oh no, no, that makes sense. That makes sense. Sorry. Okay.
well, you can if you add something like any. But but hey, I don't think you want to do that. So
But
that's
we
fine.
don't have the labels, man. How are we gonna do that? Oh no, but it doesn't matter because the
Mm,
labels are already
yeah,
in the new
the
environment.
logic is the same idea. That's the point.
We already have those. So what should we do? No, but it is inside the environment, but we don't know that. We don't know, oh, I want to do a plus with x and y. How are you going to know that x and y are being applied this native function?
Because because plus is a thing that is with a type native func, and then we know what are the types, and then we just need to spit what are the types for the abstraction.
We need to spit the
Thinking of
types.
evaluating the arguments, that's the application. We're thinking of only the abstraction.
No, I'm thinking only about the abstraction. So we have a lambda, we have exactly this, right? So this is a native function, right?
Yeah.
But in that function, type check abstraction with native functions, we don't know which people we are doing a plus,
Yeah,
right?
they're variables that should be in the environment.
Yeah, but we have those in the environment, but we need to look up. How are we going to look up X if we don't have access
Well,
to X?
what do you mean you don't have X to X?
Where in
Oh,
here?
on the native func, you mean?
Yeah, we don't. Is it in the body? And I'm going crazy?
Because a native
No,
func.
this
Let
body
me
doesn't
think.
exist actually.
Because yeah, it doesn't exist on a native
Yeah,
func.
exactly. So we don't know. Um,
But dude, like, think about this. The function. Oh, dude, no, never mind. Like, look at the return type. For we should just split function, then the variadic info. By default, I think all the native functions they are variadic, right?
I'm not sure,
And
but
then
anyway.
I think they are. And then just the types and return type. We just need to match exactly what is there, and then we handle as a normal abstraction,
Uh,
like line 10
10,
down.
10 down. So you mean this?
Let me see. Yes. So we already have all of that.
Yeah, but I'm not getting how we're gonna discover.
The body you don't, because the body is already inside the thing. You don't care. You just check that on the application if they conform with the input types on the function.
Oh, so the type check application will have a native variation here.
Yeah, you no, you don't need to do that. If you do, that's what I'm saying. You don't need to do that if you understand the native function and you spit the same structure as an abstraction, which you can.
You spit the same structure as abstraction, which is a
Like,
function.
for example, a plus. What does a plus do? It takes many things. It's a rest integer.
Oh, so you
I don't know.
mean function,
Yes.
not variadic?
No. Variadic, right?
Oh, I'm not sure, by the way.
Check. I do think they are all variadic. Oh no, no, they're not. Like less than.
Yeah, the less than and stuff like that.
Okay, yeah, that's garbage. Just,
That's garbage.
but I think you can pass that information as well. It's not a problem.
No, it is a problem. You know why? Because this will pick the new environment with the x and the y, and this will pick the plus, right?
But
This will pick the
the
plus.
environment doesn't matter, man, because we don't have the body on a native function. Like the body doesn't exist on a native function because it's not something definable. It's already like inbuilt the evaluator.
Man,
We just have the top level. Like it takes this and it spits this. That's all we
I
have.
think it needs to be this, man.
What? No, man. No, dude. No, dude. No, no, no.
You
Dude,
know,
like,
wait.
no, no,
Let me
no.
explain. What is this? This is a return type, right?
Dude, you're thinking of checking the parameters with the body of the thing. That's wrong. Because you're thinking of a normal function. That normal function, you do that. But in an abstraction, in a native function, you don't have a body.
In a native function, you don't have a body.
Like, go through the prelude. What is the body of a native, of like a less than?
Choose. Well, we don't have a body per se because we don't have the notation with the brackets and stuff like that.
No, don't think of the notation or anything. Like, what is the body of that?
Isn't the sequence of arguments to it?
No,
No.
that's not a body. That's the evaluation thing. That's another level of abstraction. What we are talking here is about like go to the simple.sw. The body is that like x, like multiplication x y, right?
Mm-hmm.
And the body is abstracted. But like look at lambda, I think it's easier. The body of lambda is an application of the native function asterisk like multiplication xy.
Yeah, but how are we gonna type check to not allow this, for instance? That's my question.
Yeah, so that's what I'm saying. We should have a type for multiplication. What is the type for multiplication? Think in terms of a lambda, a normal abstraction.
Oh, uh, it
Like
picks.
make a multiplication lambda, please. I think it's
Okay.
easier.
Okay. So lambda.
No, don't put like parameters. Just do a lambda.
You mean,
Uh,
what do you mean by don't put parameters?
just make a lambda without any parameters, not an application, just an abstraction.
Oh, um, x, and then I'm gonna put num for now. Y. Actually, no, all of this is wrong. It needs to be this, 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 this.
Oh, man, the CD is stuck again. Kill me.
Yeah, I'm gonna make it a simplest one because using the variadic is gonna be complicated
No,
because
but it needs to be the variadic. But anyway, well,
you're gonna have to use a fold then.
no, dude, just make it like abstractive level. Don't worry about this.
There's gonna be, I don't know, rest one time
And dot,
dot dot
whatever.
dot. Yeah,
Yeah, okay. So that is the body, right?
yeah.
So what is the type of this? Like write in terms of this. Don't think of the native func, whatever. Just write this.
But the type of this is a function, right?
Yes.
That is
Type that.
variadic.
Yes, type that, please.
Okay, so it's a function, variadic,
Yeah.
and then we have a list of
Mm-hmm.
tuples.
Mm-hmm.
In this case, it's gonna be rest.
Integer.
I think it's the opposite. Num rest,
Oh yeah.
and then the body,
Which
which
returns
is
an integer.
which returns an integer. Well, num
So
in
you
this
already
case.
know that. That's what I'm saying.
You already know that.
Yeah, we just need to add that on the prelude. We already have all that info.
Oh,
So you just add, and then on the
that's
match,
very interesting.
you just do okay. So this thing is variadic. This thing has null rest, blah blah blah, whatever, and it returns this. So you just convert to a function, a normal function, and then you just handle as the normal function. You don't need to worry.
You just handle it as a normal function.
Yeah, because we already handle functions, right? Normal functions. So we
Yeah,
just need to speed the same thing as a function is expecting.
but
We don't need to make
we're
a
gonna have to
whole
pattern match those, right?
yeah, well, I don't know how we're gonna do that, but just go to the prelude and look at how we are inserting. Go yes, there.
Whoa.
Native func, yes, there. See, so it's all just native func and then the thing. Just do with adding the types there, but it gotta be exactly like you expect, right? Just remove the function, like we don't need that.
Is this how you do atoms? I already forgot.
No, it's just the atom, just the word in lowercase. But you don't need the function. Or if you want to add, actually, yeah, okay. If you want to add everything, that's fine. That's actually easier. Yeah.
If you wanna add everything, that's actually easier. Oh man. How are you gonna solve this one? This is an unary function, which we don't have a. Uh,
Oh, it's a bool, right? Oh, wait. Unary. Well, unary just takes one. So it's the same notation. It just takes.
let's read in the prelude. Comparison, comparison, logical, logical. Unary, it's a not. Okay, so it's a boolean in this case. Oops. I have no idea how you're gonna make this work though. Okay, so copy this. Copy. This is the comparison. So this needs to mean that it is. Is this using a fold? No. So it's a not variadic, right?
I don't know.
I don't know.
I don't know, man.
Oh, this is
The
wrong, man. You know why it's wrong?
comparison. A comparison func is just like less than, right? So
Yeah,
it's
but we
all
don't know the
binary.
names, man. The names are in the environment.
What's the problem? No, what?
What do you mean, man?
What are you talking about, man?
Okay, so a function is composed out of four things.
Hmm.
an atom for identification, an information if it's variadic or not, a
Yes.
list of parameters, and a
Yeah,
return
which
type.
you just care about the type. You don't care about the rest there.
Oh,
So
we
it
don't
can
care
be
about
like,
the
I don't know,
rest.
X. It can be A, B. Like, who cares? No, no. As Yeah, you can do that, but that would be different than the function notation. So just do as a normal thing, as a normal parameter. I
Oh,
don't
you
think you can do that.
you think it's like this?
No, 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 man. Do the same thing as a normal thing, like as a normal function. But you don't care about the name because you don't have a body, so the name doesn't matter.
No, that part I got it. But you're always gonna have to have in a comparison two guys, two booleans.
Yes. So just make a normal boolean.
No, a
Like,
comparison you have only numbers, by the way. The boolean is a return type.
okay, yes, that's true. No, but like it should be as an A B, like a tuple as well.
Oh,
Integer A, integer B. I don't think you can do that.
really?
I don't know, man.
Let's pray for a bit, just for lols. It's gonna be
I don't
funny.
know. Man. I wouldn't waste my time. Oh, but
uh,
you're not learning how it works. Yes, but that is just bull, I guess, right?
yeah.
Yeah.
The arithmetic is always an integer and it's variadic, if I'm not mistaken. The logical, where is the logical?
The
Comparison.
correct way to implement this actually would be allowing you to pass the types you want,
Yeah, that would be the correct way of doing it.
but we want to move fast.
It's not exactly because of that, it's because Lisp also does that. Uh,
Not really.
no,
Like
you
the
cannot
not
choose,
the
but you don't have to
no.
put the types in there.
For example, the unary. Like the unary, we're handling as not as a boolean, but like it might not be. Like it
Yeah,
might
it might
be.
not be, might not be.
But
Okay, let's
who
see.
cares?
The
But I don't
comparison
care.
is here. The arithmetic is here. The unary
Yeah.
is here. Okay, so where the heck?
Oh,
Oh,
oh, oh. Ooh, ooh, ooh.
it's unbound.
Hey, hey, hey. I saw. I
So
told
you
you.
do
It's a waste
need.
of time.
He's still complaining though. Oh, I need to
Save.
save it.
Yes. Garbage levels of tooling, man.
Garbage levels of tool. This is Emacs, by the way.
No, no. This is not a problem with Emacs. This is the problem with the LSP. Okay.
Where the heck we're gonna discover that this is a native function?
Well, there is written native func and then the type. You just sheet the type, output type, which you're already doing. So that's it.
No, but this is wrong.
No, that's right.
No, this is wrong
Why?
because we added choose things, I guess, right?
No. You added one thing. Look at the prelude. You added one thing that is already the type.
No, I added this.
No, dude. Yes, which is the type. That is the final type, man.
Okay, so we need to forget about
No, no. What? That's a type already.
no, the output type is the last one.
What are you doing, man? Dude, what the heck, man?
No, let's go to the prelude again.
No, man.
Let's go to
Like,
the prelude again. Let's count. One,
yes, chew. You just
two.
want to chew. No, 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 no. You want the entire line one.
Oh, the entire line. I see.
Yes.
Uh, and we don't care about the function itself.
Yeah, who cares for that crap? Right,
Who
that's it.
cares?
Oh, by the way, you need the semicolon. Oh
No.
yeah, when you do that, it allows you to do a new pattern matching, so it automatically does that. Just curious, yeah.
Are you
Okay.
sure?
Is it comma or semicolon? No, it's not it's not colon. It must be semicolon.
Oh, variable
It's
environment is
semicolon.
unused.
It's semicolon, man. I'm pretty sure because it's not gonna define now the next abstraction.
It's semicolon.
Yes. Well, not easier. And
Are
what is
you
the wrong
sure?
with it? I am absolutely sure. What's wrong with that line? Head mismatch. Okay, because the two of them have two different things. So just do the following. Okay, on the there should be a third parameter on the abstraction. Yeah, just put yeah, whatever. No, no. Yes, okay, that's right. All right, now go back to the application.
No, go
No,
back
we're
to the
not
application.
finished. Check if you're passing the native function there.
Check if I'm passing the native function here.
Where are you getting the abstraction? There on the line 12.
Here.
So yeah, so we're passing the abstraction.
Yeah, it's totally
And
on the
then
hands
but
of
we
the
don't
this.
yes, but we don't have a body. So we need to make a new thing there. Go back to the type check with environment. Up there. So make a new case for instead of matching abstraction, matching a native func. Mm.
Uh,
And
type,
then
um, and then function, I guess.
actually I could have already returned it there, right?
Oh yeah, we could. And then you just return this.
Yeah, okay. Just delete the other then. Yeah.
Hello Nathan, how are you doing?
Check if that is right. I think that's now wrong because there are three parameters if I'm not mistaken. Go up there.
It's complaining about type check with environment at
Go
this
up
point.
there. I just said that. Abstraction. Yeah, semicolon. But wait, that is. Oh no, that's right. That's just two. Comment the yeah the shit.
Is Nathan
Okay.
speaking on the chat and I'm not?
Oh yes, I wasn't ready. Let me see.
Just woke up. Yeah.
Oh, I imagine. Yeah.
All of us imagine that. Yeah, source. Uh,
I don't remember which one.
type.
Type. Typer. Yeah. Elf. Um,
Same thing. Oh, but now we are printing. Where are we printing native func whatever?
No idea, but I.
Oh, it's because we changed also the prelude. Okay, so it's faster to do it like that.
Yeah, okay. Dun,
It is
dun.
wrong.
We are
Yay.
mapping a function inside a native function. Okay, that's wrong. Now it's just on the top level. I don't know where we're doing that.
Where are we printing this stuff?
Good question. I think it's down there, the last thing. But I think it's on the application. Let's pay attention.
Application. This one.
Yeah, because look
Oh,
at look
it's
at the
this
terminal
one.
again.
It's this.
Look at the terminal again. We are wrapping like we are converting correctly. You see? Oh no,
Uh,
that's right. Actually, no, 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 that's the wrong thing. Yeah, that's right. That's the correct one.
no, this is wrong,
Native
right?
funk. No, no, that's right. That's the native funk plus the type he has
No, no,
and
no.
the thing.
Yeah, but where are we printing that? That's what I'm not getting.
Well, it's down there on the what the fuck.
Yeah, so which means that this didn't work
This
because it
video is
should
going
have
left,
matched
right,
this,
left.
right? The variadic one.
No, it matched another thing, like which is nothing. We are not matching a native function.
Okay, so let's do that. So it's gonna be. No, wait. Why do we want to match a native function? Shouldn't we discard this and just keeps this?
Yes, the type. Yes, we don't need to do that on the type check with environment thing.
Yeah, but that. This is what I got. This is what I thought we were doing before.
No, this we I was thinking of doing that on this top level, but we are in an abstraction, so it's not matching that. It's matching the
Oh,
abstraction.
okay. So we do need to have in that other way.
Yeah.
Okay, that's
No, 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 you don't. No, no, you
what?
don't.
I'm confused.
Like, look at the case. Go to the abstraction, no, application. Sorry,
Hmm.
where. Mm, oh no! Yes, you do.
Yeah, you do.
Yeah, you do. Yeah, you do. But wait, dude. No, no, no. Go back. No. No, dude, go back to what we were doing. Like that was right.
What we
To
were?
the type
Which
check
one?
that on the type check with environment. Sorry, I'm speaking like Joe Biden already. I can't speak properly. Okay, a native what?
I don't know what is
What?
complaining. Function.
Type
Oh,
check.
undefined. It's because there is this wrong.
Okay, I see. Okay,
Yeah. So
so
what we need to change at
okay,
some
so
point.
now go to the abstraction. Is the
Okay.
abstraction is wrong now? No,
Okay.
sorry, application. Oh man, that's stupid. Sorry, my
Application.
brain's
Here
fried.
it is.
Yeah, so we are trying to type check the abstraction,
We are
but
classifying a native function as abstraction.
yes, but that thing is already evaluated, so we don't need to do that.
No, we're not evaluating
So
anything.
there, I know, but we are handling it as if we were. So what I'm suggesting, we either do another function.
Just 1 second, Maggot.
Hmm. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun.
Okay, I'm back.
Dun, 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 dun,
Okay,
dun,
so
dun,
go on.
dun,
Go
dun.
on.
Okay, so what will that return, that case?
At this point in time, it will return this.
Yes, but why? Because it should be returning the function, which is the second thing.
Yeah, it should be returning this guy.
Yeah, so are we pattern matching wrong? That's my question.
Potentially, maybe. So let's
Oh,
see.
no, it's not. It's right. Go down there. I get it. So
Down
look
there.
down. Mhm, mhm. Let me see the cases. No, it should be wrong actually, because the only two cases are the function, right? Yeah. Yeah, go to the type check with environment again.
Just a sec. I just want to make sure that I'm not crazy about the thing here.
I should have been driving this because I can use now the tilde. I need reasons to use it.
The only reason why is because I now have a better keyboard.
Oh man, I think I was doing something XML with Clojure, and then I just typed that because like macros you do with that. I said, oh man, I feel so happy. I feel like variable. Okay, so that's right. But the evaluation is wrong, so
No,
I
no, no,
think
wait,
they
wait, wait,
are
wait,
not
wait, wait, wait.
matching.
There is an extra print here. I think that this is this abstraction.
No, I don't think so. I think it's the variable
No, where is this being
multiplication.
printed? Because it was
The
up before.
print with a string. I don't know, like something to identify. I can't read that.
Yeah.
And illiterate. It might be matching twice though, because there are two things there
That's
mapping. There,
possible though.
there are two abstractions. Yes. Yes,
See,
it is.
it is
Okay, so it's
matching
on the second. Yeah,
twice.
so the second is wrong because it evaluates to native function. Should be just function variadic. Oh, varidic. I just noticed you mistyped.
Yeah.
But
I
anyway,
also
just go
noticed.
varidic. Okay.
Oh man, so cool. So cool. Oh, the logical operators, they are also variadic. We have cursed logical
Oh
operators.
yes, that's true.
Okay, so the first
But
time it
no,
does it,
but
it is
go.
correct.
Yeah, but go back. Yeah, but that doesn't matter. The problem is the native func. Go again to the type check with environment blah blah definition.
Hmm.
Up there, this native func type. Dude, can you print there? What is the type? Am I going crazy here?
I think yes, because this doesn't make any sense to me. Because let's think a little bit. This is the abstraction that we're gonna type check
Oh,
in
but
the
man, like,
application. No,
dude.
no, no, just listen for a sec. So this is this, right?
Oh, we're stupid. We're stupid. We're
No,
stupid.
that I
We're
also
stupid.
know,
No, no,
but
no. No, but man, like, look at this. We're totally retarded. Look at what we are printing. look at, look at what we are printing. No, serious. Look at what we are printing
Where?
on the terminal.
Hmm.
E colon space variable
X.
asterisk.
Yeah.
What is that? We need to get
It's
that from the
this.
environment. No, wait. Yes. So what is the type of that? Nothing. So we need to get that in the environment and then see. That's why it's returning native func because it's
Oh.
evaluating a variable and just spitting the garbage. So yeah, yeah,
It is in here.
yeah. You can
Uh,
do it there, but that's just getting messy.
I,
No, no, no. That will not. Yeah, okay, you can do that. That's kind of cursed, but
that's
okay.
not cursed, man. Because in our implementation, native functions and variables are treated in the same manner.
Yeah, okay. That's fine. But so like you can remove from the type with environment up there.
Yeah. Something is wrong.
Oh, column. Semicolon.
Okay. Now we're talking.
Now please garbage work.
Source type.
Let me see. Nathan sent something here. Uh, folks, didn't we
Yeah,
need
we,
to
we
change
we
some
also
matches
yeah we
to
also
ignore
thought
the
it was
type?
that, but then we remember that we are not type checking native functions. We remember that today, by the way.
That's man, that's not a thing.
In
Uh,
here it is.
no, like that's literally just having the type in the environment.
Yeah,
Yes,
that's
but
what
we
we're
did.
doing now.
That's the thing. It was done.
No, it was
No, it
not.
wasn't.
It wasn't.
We have a prelude, right?
Yeah.
Don't we have for values and for types?
No,
No.
we
We
added.
don't?
No.
We added it now. That's
We
what we
added
did.
now.
Doesn't make any, no, you guys were not making
Dude,
doing
we
that.
just had native function and then the fun. That's it.
Man, can you show me where is the map? Like for the initial prelude for types?
I
Yeah.
mean, load the
No, we don't
GitHub.
have a prelude for types.
Yes, that's what I'm saying. Open meta Ctrl X G.
Like you have a map somewhere, right?
Yeah,
Ctrl
we
X
have this
G.
map. No, no, wait a
Ctrl X
second.
G, man.
Wait!
Just show the difference. Save.
Uh,
Why do you need to save scrap? Just do tab. Yeah. There.
Uh, huh?
yeah, we added to the prelude the types for native functions. Because before
Is
we didn't.
is that you adding to the map?
Yeah,
To the initial one?
yeah,
So okay, that is the type of what we had in the prelude, right?
yeah, now it is.
Oh, okay. So you guys were just trying to match the type of the value, right?
Yeah, we are now better matching the native function because a variable in our
Pattern
language,
matching the native function where
in the variable type checking.
why?
Because in our language, a variable and a native function they are parsed the same way.
Because
Well,
when you
they are
send
the
to the
same.
evaluation, it will like fetch the value in the environment and then the thing there,
Yeah,
we
but the
already
only
have
thing that
access
was
to the
happening
type.
before is when you were type checking a variable, it was trying to find that in a map, right? In the map, like, oh, you have an x and the x is an integer, cool for you. But the native functions, because
Mm.
they didn't have the type information embedded in them, they didn't have any type at all. So we
Oh,
added this, and now the type variable will try to pattern match the native function and return this.
oh, okay. Let me see if I got. So yeah. So what you guys did is, uh, oh wait, yeah. So in that environment that we had the native functions before, uh, you guys just added there some. part of the structure
This is
to
the
have
environment. This is
types there?
prelude. This was the prelude.
Okay,
You see that the native function, it is informing it is native, it is informing its
sure.
functionality, but we don't know the type.
Okay, so you just added the type
Yeah,
there and adjusted the rest?
yeah.
Yeah, that's bad, man. So, man, so it is a variable, like in exactly the same way regarding typing. And eval well, for typing. Uh, can you show me where you call the type checking function?
After parsing, immediately after parsing.
No, but show me that.
I think,
Like,
Nathan, that your idea was to make a type per prelude different than the evaluator prelude.
yeah, because we need that.
No, we don't. This
No,
approach
no,
that
we
Magenta
don't because
made.
we are gonna bury this project today. That's why we don't.
Well,
Don't listen to
really.
Magenta, Nathan. He doesn't care.
Yes, I don't. This
Uh,
point,
type check est. Okay, so go into that function for me.
this point to just be pragmatic.
Uh,
Anyway, I'll be back.
prelude. Okay, this prelude is the same
Yeah,
one for the eval.
yeah.
Yeah, you see, that doesn't make sense. Why do you need values there? We don't.
Uh, how can I explain? The idea was to have the same EST for both, but they are looking at different parts of the EST.
The same AST.
Yeah, the
You
type the
mean,
typer is not changing the EST, removing the types.
well, it is not. It's just checking, right?
Yeah, but it could do that. Uh,
I don't know why it would.
because it doesn't make sense to the evaluator to have access to the types.
Oh, that's why he can just ignore it. That's what.
No, but that's what I mean. At the same time that the evaluator can ignore the types, the typer can ignore the values. It's kind of
Yeah,
like
but that's no, that's a different thing because okay, yeah. For the evaluator, you are ignoring the types in the EST because, well, you need to work with the EST in that way. Otherwise, you have to remove during the typing. But you see, he's checking and returning a transformed AST. Like it's a different thing. He's just not checking. Okay. He's
mm-mm.
not just checking.
in our
Uh,
in our implementation, it is just checking.
no. What I just said is, if you want for him to remove the types, you have to transform.
Oh no, but that's
In
I don't
that
want to do that.
scenario, you are not just checking. That's what I mean. Not what we are doing.
No, yeah, but yeah,
But there, you are like quote unquote ignoring the values, but you are talking about the map that you are passing them.
yeah.
Uh, that's already strange because the map has a, let's call it namespace also. That's basically, oh, okay, X means something here, right? And
Mm-hmm.
since we don't have types in the language, that's not really a problem. But see, like you have X, and if it's something is unbounded, he will like fetch a value, right? Because he didn't overwrite it with a type. So maybe you are
I got lost. What is fetching a value exactly?
okay. So let's suppose we find the variable X, right?
Mm-hmm. So like
In the
this one,
type
for
check.
so I don't know, like
Any variable X,
this
right?
one.
Yeah, like we have a variable X. And basically, how do I type check a variable? I just look in the environment, right?
Mm-hmm.
And what if it's unbounded, but for some reason it has a value there?
No,
Like
but it's not.
unbounded in the sense that it was not bounded for a type in our map. It has a value with this key there.
It has a value. That I don't know what this. The typer should never be able to do that, as far as I know.
Well, but if you are initializing the prelude with values there, we already have that.
No, I'm not initializing the prelude
Oh,
with
okay, yeah,
values.
yeah, because you included all the. Oh, yeah, that's true. You included. It's I think that's fair, but I think that's really troublesome because what you guys did is instead of just adding types in a map, you guys like had to change code and doing special cases. But well, sure it
No,
works.
but the native function is kind of special case in this case because it needs to be treated differently.
It doesn't.
All,
Like,
it's only
It's
the
not really
same.
a special case. It's just we're just adding the
No, no, no.
case for native function on the
No, 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 but
variable
Nathan
match.
is right in this regard, Magetta. If we had a separate prelude just for the typer, instead of having this like this, it would be, I don't know, integer for the inputs and integer for the outputs. And it would be treated exactly as a normal variable.
Magetta, because
Okay,
like the
you
native
want to adapt
function,
it as a normal variable notational type. Yeah,
Yeah, what we are
yeah,
doing here is reusing the same prelude that we use for the evaluator, adding the type information there.
what is step one? Adding to a map, like modifying that. But the other thing is that we had to modify the code, right? And as you guys are seeing, that can be troubles.
Oh, let me stop. Let me mark the page here. Oh man, page 427.
Is it still recognizing the... It's not pattern matching the variable, man.
Thing? What?
Look at
Not
here.
recognizing.
Yeah, look at
What?
here. So, uh, okay, I want to do a final test. So test type check with environment passing. This is the native function in this case. Then we're gonna also print that in here.
Change the E to O, like output.
Creative, I like it. Source typer this. It is complaining. Line 67 will always matches. What?
Control X, Control L. No, sorry, Control G, Control X, L. That's not 67.
That's
No,
surprising. He can check that.
69.
it's
Okay.
69 actually, so it's this one.
Yeah.
It is saying that it will always match. What do
Like
you
you are
mean?
binding the type to like anything, right? So the second case can never happen. I'm just surprised that he's checking for that.
Oh yes, that's true. Oh yeah, that's true. So change the order. Yeah. Yeah, that's true. Yeah, I'm surprised it's such checking for that.
uh, it worked.
Okay.
It
Yeah,
worked.
that's right.
Okay.
Now it's
So,
another garbage.
okay. So
That's
what
not
are
the
those
very
prints
anytime.
anymore? So it's printing this. Okay, now we are reaching this part. So we have two things being printed. The first one is the var type args, which has an integer and integers in a boolean. That sounds really bad.
Okay.
That
But I
seems
think
really bad.
that's right. Right? Integer. That's a multiplication. Okay, those are the what?
Where is
Wait.
the
No.
boolean coming from?
Yeah, that doesn't make sense. What the heck?
Maybe it is this boolean though.
Oh, yes. It's from the whole thing, right? Because I think there was a condition there as well.
No, but we are pattern matching this, which comes from this, which is the type of the native function multiplication. Then, what we
Mm-hmm.
are doing with it? We are getting the types
Minus one guy.
minus 1, which is 0, right? Because
I
this
don't know
is
if
1.
that's because the size goes to until minus n minus one, or we're just excluding one.
Oh, this is the non-variadic amount of the types parameters. Okay, so this is 0. This is correct. Then we go
Not
to
that.
0 to argument types. What is argument types?
Oh man, I totally understand that, dude. I become a farmer
Okay,
in the
so
future.
it
Okay.
is.
So let
Um,
me see what you're saying. Check application.
we
I
should have
well,
numbers. We should have numbers in argument types. Let's check if that's correct. Argument types is unbound. Oh, arguments. Oh. What? It's not printing.
it is.
It is? Where?
Oh no, it's not really. Yeah.
No, maybe it is, but I am making a confusion with
Mm,
the amount of enters.
mm, No, that's right.
No, yeah, now it is.
What? A space? What the heck, man?
Boolean. Oh, I know.
Oh
Okay,
no. Okay.
okay, we are trying.
Yeah, that's stupid.
We are trying
Okay,
to
so
multiply two numbers in a boolean.
yeah,
Okay.
that's right.
Okay, cool. Um. Okay, so how does this work? So this is the argument types, which makes sense.
Mm-hmm. Yeah.
Let's go back here. So this is 0, and we are splitting at 0 a list.
I'm sorry. This is just funny.
Is this how you do a list? I already forgot.
Dude, is this to get the head of the thing? Like that
No.
would be very
No, no, no,
stupid.
no. It's because no. This is not to get the head. This is because we are assuming that the variadic function may have non-variadic arguments. But this is not
Oh,
a case
okay.
for a native function.
Yes, yes.
Um, okay, cool. It works. So everything is variadic. This all it is very classified as variadic part of the types of the things.
Mm-hmm.
So this is the argument. Now we need to do the types, right?
Now var type args, var type. Oh wait, sorry. Var type args. Sorry, non-var type sig is equals to the non-var type args, which both are empty.
Both are empty in this case.
So it goes inside the garbage and then it does list all. Okay, for all the garbages inside the var type args, they are with the same signature of the thing that we specified in the variadic only variadic argument.
Yeah, I
If
guess.
that is true, we just split the return type.
Yeah, and it
That's
is working because the arrow that is throwing is type of variadic argument does not match variadic type of the signature, which is this error. So it is entering this if.
mm-hmm.
It is going through. Then we are doing the following. We are checking if all the variadic type args, which should be integer in our case, if they are equal to
Yeah. Can you print the two? Let's see what is inside.
IO F right B. I need another letter here. Let's put K.
Okay.
So var type args and var type sig.
I don't know why you suddenly needed a space there. Doesn't make sense.
Where?
No, no, like on the P, like you added a space and started working up
Oh.
there. Yeah. No, no, but that's not working, right? Oh, it
Okay.
does. No,
Okay.
it does.
Makes
Okay.
sense. Okay, so this is correct. Because the var type args are the args that are coming to be applied.
Oh no, wait, but that's wrong.
Yeah, we need to
Like,
remove the
yeah, we need to
rest.
unpack. Yeah, we need to unpack.
How we
Yes.
are doing that in the tests, by the way? I think these tests we're not considering that though.
Yeah, just to do an unpacking. We can do a pattern match in there as well.
Um,
Like in that case, it will always be like that, so that's fine.
No, it will not always be like that because
Well, variadic, yes.
not all native functions are variadic.
No, on variadic signatures, there will always be, because this is the case where it's variadic already.
Oh, okay, I see what you mean. Okay, so we need to pattern match. Um, okay, so let's call. Holy crap! Variadic type. Okay.
In the palm of the book,
Wait, is this correct?
all of the book, in the palm of
Rest
the book, embora a solidão.
integer.
Uh, uh, uh,
No
uh.
match of right hand side value. Type checker application line 79. 79.
What are you printing? Let me see. Ver type sig.
Here. So this is the where after passing this to the type checking variable.
No,
And
but that is right there.
this is
The
correct.
problem is the K. Oh, okay. Okay. The pattern matching is wrong then. Oh, if you guys know why.
Non-type args.
Oh, go back there. No, it's the line 12 that
Line
is wrong.
12 down, you mean? Here.
Yeah.
What is wrong?
Mm-hmm. Go back there. The pattern matching.
Oh,
No, go back to the terminal, man.
oh, where?
There. Right hand side is empty, and then there's a list with an integer rest. So it's another list.
Oh, it's because of the this is a list. I cannot type check like that. I need to get the head. Um,
Beautiful.
I don't know if I would call it like that, but.
No, man, I seen things way worse. Oh, that's why I was doing like that. Okay, that's why we were doing wrapping it in a parenthesis there, like squared brackets. See? Yeah, just unpack that
Rest
garbage,
type
please.
lists. We don't have that.
You can just unpack, man.
No, man. We can't just unpack. We need to grab the head.
No, you can, dude. What are you saying, man? What are you saying, limos? You can.
No, this is a list, man.
No, but yes, but you're getting the first, so you can use head. By the way,
I, oh, it's not head. It's HD.
HD, yes,
Uh,
but you can use that, and on the rest type, you can just remove the rest.
yeah,
Is it the first or the second? I don't recall.
it is the first.
Remove the parentheses. That's wrong. The squared brackets on the
Remove.
X. X is squared brackets. Rabbit. Yeah. Oh,
No.
wait.
Undefined function list HD. We
Oh,
don't
it's
have
just
that.
it's from Erlang. It's from Erlang. So we just remove that the predicate, the lists garbage. Just remove. Yeah, HD. Now you have it. Oh, oh,
Wait, what is the type of
oh,
this? Integer.
oh,
Nice.
oh, oh, oh.
Hey,
Okay,
Halo style.
nice. Hello, Stan.
Okay, so we know how to pattern match stuff and native.
Dun, 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 dun. Just remember the OST. Let me actually put it here just to get in the mood.
Oh boy. Oh boy. Let's try to break it.
Halo soundtrack. Bungie. Perfect. Okay, so what you're trying to do now?
Oh, no. Something is wrong. So, wait, I already saved the file. How is that possible? Oh, I didn't. Okay. Integer 4, boolean, variable, boolean, false. Why is not throwing the why is not formatting the error as we want, man?
I don't know. The type. It's not because it's not a format.
What do you mean?
It's just you're handling as a string.
Yeah, I'm passing it
Yeah,
to.
the error doesn't do that.
So there is a way to do that.
IO format, and then you make a new string. It's like a S printf garbage.
Are you
Look at that
sure?
beautiful. Look at that beautiful documentation. That's amazing. I love it.
Okay, format and data. Data is a list. I think it's format 2 then. So it's
Oh, do like this meta x and yas, like in California,
yes.
like yas.
I don't know what you mean.
No, like yes, but like Californian yes. No, no, yes, yes. Uh, minor. I don't remember if it's a minor mode. I guess something like this. Yes, minor mode It's the same thing you use for Haskell. Yeah. Now you can type and then it fills the crap. Like IO format and then it fills the parameters for you. Doesn't do that crap.
No, that's cool. Okay, let's try in here. So IO format.
Yeah, but
Oh, like
yeah.
in Haskell. Okay, cool.
hmm
But unfortunately, it's not smart enough to
Yeah,
figure
but
out
I
the.
don't know if it the result of this is a string.
We're
I'm not
gonna
sure.
discover right now.
Yeah, try doing.
Yeah! Holy! It works!
Wait,
And that's how I'm gonna do in LFA as well. Good to know.
wait. What is that exception?
It is thing. Type. The
Oh, okay,
exception is
yes,
okay,
yes,
by the
yes, yes,
way.
yes.
It is not bad, it's just okay.
Yeah, yeah. Okay, that's trash. That's the only trashy part, but that's fine.
Okay, let's add that. Man, we have our own error message. That's cool.
Well, they're shitty, but okay.
No, they are enough for what you're doing.
Everything that touches Erlang, it's like the anti-Midas touch.
Format.
No, I think not sent a message. Let's see. Short-handing go.
Yeah, I will use that in the
Oh,
bot as well.
that's cursed. Actually, oh man, I was talking to Victor. I even prefer. Oh man, Victor is gonna go to a Gopher conference. That's so funny. Gopher Con. Please bring me a plushie.
I have a quite no. We can talk about that later, but I do want to understand what exactly Victor does because if he's working with you, isn't he using F sharp?
As is. He
But
just like was working with Go before.
oh,
He's a golfer, so
Lemons, but we all do the same, man. Don't we work with like better language outside the job?
languages outside the job.
we all do the same. That's very. I don't know. It's speaking a lot, lots.
Yeah, it's ironic that we are doing this in Erlang, right?
uh,
Man.
okay. Oh, I forgot.
Ta-ta-ta-tan,
Examples.
ta-ta-ta-tan, ta-ta-ta-tan,
Um,
tan-tan-tan-tan-tan.
simple. SW. Dot. Go. There it is.
But is that wrong?
Type of, yeah, that is wrong. Type of variable, type of variadic argument in x, y, x, y, and the
Oh
literal boolean.
no, it's not fetching the stuff in the variable, is it?
No,
Like
this should be wrong, man.
yeah, but no, but wait, like I'm saying, it should fetch the x and the y in the environment, isn't it? What is the st? I don't recall.
The ST is like this, man.
Okay, the x and the y, they are already in the. Okay, they're part of the body, right?
Yeah,
Not the arguments.
and it is saying that the x, y, because this is the body in this case, right?
Hmm.
No, not the body. This is the arguments of the body because the body is application. And then we are okay. So we want to do multiplication. Does not match
Yeah,
periodic type of the
yeah,
signature in
but
the
that's the
abstraction. This
problem, right? The problem is that it's not. Actually, I don't know because
It doesn't say you shit.
you're just printing the application that does not converting anything. That's not showing if
no,
it's
this is
doing
not
anything.
saying that x is an integer, y is an integer, and then
Yeah, but
boolean,
that
the false is
shouldn't,
a
right?
boolean.
Yeah, but that shouldn't.
No, helpful error messages would say that this is not a number.
No, yeah. Okay, let me rephrase. It should, but at that point, it's not doing anything like that. Like you're just printing the application. That doesn't mean anything.
Yeah. Uh, okay, now finally, with 10 minutes remaining, we need to change the evaluator EST.
Oh no way, man.
I'm sorry. I'm not dragging this to Tuesday. I'm very sorry.
No, I mean no way. I thought you guys did this as the first thing.
No. We first spent a little bit of time remembering how you update knife from spoon
Yeah.
because we both forgot. And then we spent this time adding the native functions to the whole thing because we forgot to do that before.
Yeah, we need to discover that we needed to do that. That's the
Yeah, we need
problem.
to discover. Okay, that shouldn't be that hard though, because as far as I can tell, only the
It's just
closure is wrong.
adapting the ST. Yeah. I don't know if it's
Um,
just the closure, but we need to adapt. That's for sure.
okay, so let's go from the beginning. Where is the condition here? Do you have an eval condition in here? Closure. Oh, here. Okay, so this is assuming environment case then else. Then we are evaluating the case, and if it is, we involve the then. I think that the condition is already done.
They need to be bool. Yeah, that seems fine.
And now that we know how to do stuff, let me add here.
We are not stupid. Oh,
Okay,
that doesn't mean much things, man.
what do you mean?
Well, they're just like sending back the thing that the guy already knows. So
No, the
and
guy
there's not
didn't. No, the guy would be asking,
there
okay,
was not the
which
comma.
expression cannot be
Comma.
reduced to a boolean? That's now it's gonna know.
Yeah. Okay. Yeah.
And why
Comma.
this is wrong?
Remove the comma. Comma.
This format string requires an empty argument list with arguments. What? Oh,
Oh. Yeah. P.
expression cannot be reduced to a boolean. Okay, next. What is the next easiest one? The second easiest.
Love is
Variable.
unique.
Variable, closure, native function application. We don't have variable.
Look for verbal. Oh, the
Oh,
verbal is
it's
so
here.
stupid that we do. Yeah. So variable, we just get in the environment and throw it. There we get the type and throw it. Yeah, the variable seems right as well. Drink coconut. Uh,
Okay. Next, the next easiest one, I guess, is gonna be the abstraction.
Closure.
No, the closure is the worst. Because
Okay.
this is the one that actually manages the labels, which is what we are changing in here. This is the major difference between the two ASTs. These labels are assuming to have only names, but these labels are assuming to have names and types.
Yeah, but let's do that already. So let's see. Variadic info. Da, 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 da. You know what's worse? This function is broken down. So
Broken.
it's like, yeah, it's with this is just the variadic part. There is the non-variadic down
Oh
there.
yeah, there's also the number. I'm aware. I'm aware of that. So where is the types? The types are in the first place. So we want to exclude those ones and just make labels easy. So labels is gonna be pretty much the same thing. So lists, map.
Why are we using the labels? We're
We are
just using it
using
for
them
length.
here and also here.
Isn't it just for lengths? Yes, it is. Oh no, it's for like splitting. Yeah, no. Yeah, just remove. Just do a map. Yeah, just do a map, man.
No, but now that you said, are we using the contents out of the labels at some point?
I don't know. No, we
Oh,
are.
we are
If you look
here.
at the yes. But I'm thinking, look at the rest there. Oh man. Go down. Go down. Go down.
Wait, where?
Look at the rest. Variadic name, rest. So we need to match the keyword rest we should keep.
Where? I'm not. Which line? Can you help me?
17.
Oh, here.
Yeah.
We need to invert those, right? If I'm not mistaken.
Because I was thinking of the rest as the ampersand.
No, but it is that.
Yeah, but if we're gonna map, we're gonna remove that.
Are we?
Well, I don't
Oops.
know.
Let's do a test. I don't remember, man. I think it's like this. So, rest integer.
Yeah, but the rest is a different name,
Mm,
right?
no, but it can be a different name. It can be. I'm not saying it needs to be.
Yeah, but that's
But the
confusing.
parser is complaining about that, so maybe I'm doing things wrong. Invalid character encountered.
I don't even recall what we did there.
Yeah, I also don't recall anymore. So let's consult the grammar.
Or that's a reason for us to drop it.
Abstraction. Uh, Lambda parameters. The parameters can have type variadic, which is optional. Oh, the ampersand comes before.
Oh.
Whew! Okay, but here it is. Here it is.
So it's integer rest as in which is the name. There is no like keyword rest.
I think there is. Let's change this. Oh no, you're right. The last one is always the variadic one in this case.
Yes.
Okay. Which kind of means that
This is wrong.
uh, it is wrong. But I'm thinking how we can fix this. Um, it is the type and the name.
Well, yeah.
Seems fair. Actually, it's not. It's just this. Because we're going to map it here.
Yeah, okay. Yeah.
So the types are in the first slot. So we're going to do this.
Yes, sir.
Types, labels.
Isn't it just labels? Oh, type labels. Types and labels.
Yeah.
Oh, how many names? Who cares? Just name like a variable one.
Okay, it's complaining.
Oh, but it's gonna be unmaintainable. Yes, that's the idea.
Oh, cool. Why is it still complaining?
E, 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 e. You did save.
Yeah. Error syntax before parentheses. Extra parentheses, maybe?
Oh yeah,
Yeah. Okay, I guess this is the same thing that we need to do in the eval closure not variadic splitting.
yeah.
So this is types and labels, and these are gonna be the labels from now on. Are these are not asking for any rests, right? Yeah. Okay, that's cool.
Yes, it's not.
That's cool. Okay, what else? Evolve abstraction,
There's a
evolve
part
application.
there that is asking for arguments. Did we change that? Because I don't recall having arguments on the ST. Like the keyword argument. You see? Line 7.
I think you're correct. We do have arguments, but now they are variables. If that makes sense. This is an application. Uh, yeah, aren't these variable arguments for this lambda?
I don't know.
You don't know.
Let me see. Abstraction variant. Yes, they are. Yes, yes, yes. Yes, they are. I remember it's because before they were like argument
Yeah,
integer
comma.
x.
Yeah, yeah. I remember
Argument.
that. Yeah.
Let's see what Nathan is saying here.
Uh,
Plus, we're not smart enough
they have
to not
types.
have types. Yes, I know.
Oh yeah. We are not smart enough to not have types.
I totally know that.
Um. 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 Um.
Dude, you should see gRPC in F sharp. It's
Should
like a clown. It's like a clown world.
non. I think that this is non-variadic types now. We don't have
I
to
don't
map it.
know. I don't know what it is anymore.
Things like this.
But why
Types
would you
no.
need to map the
Names.
non-variadic args?
Because apparently they are wrapped in OKs.
Why?
You're making too many questions, man.
Man, dude,
Why is it complaining, man? It's unbound. What do you mean?
is it types or args?
Oh, it's non-variadic. I'm dumb. Okay.
Today I will just play my bus
Oh, that
simulator
also doesn't make sense.
and Tetris. So happily.
No further undo information. Emacs,
It's not
what are
the
you
Mac.
doing to me?
Uh,
Clearly, we have more undo information, man. Clearly, obviously.
I don't think that was Emacs though.
Yeah, so it's not non-variadic names, indeed. Okay.
Okay, it's the second garbage. Uh,
Is this correct now? Save. Okay. Uh, what else?
dude, I just want to do Silverware Plus in a decent language. Please just finish it. Just end this torture, please.
Oh, you need to be less Nutella, Magita. I already told you that.
Dude, it's not Nutella.
Yeah, it is.
It's being resourceful. That's what I call it.
Is that it?
So the possibility of that being entirely wrong is just like
Let's see. No, let's not see now. I just want to do. Oh, eval application. Probably this is also wrong. Where is type check application? Close the environment, abstraction. No, this is still correct. Okay, let's YOLO it.
That's totally wrong, man.
Nah.
Totally wrong. There's no way that's right.
Evaluate, eval, ast.
Do a format.
How can I do that in
Meta
Emacs?
X LSP format buffer. Done.
No,
It did.
no.
Go
It
Control
removed
Z.
this stuff.
Control X, Control U.
It clearly removed the evaluation. What the? What the fuck?
Oh, it's because you didn't save the file. Go back.
Oh, okay, okay. I can accept that. We don't care about the final type of this expression, by the way. Then we're gonna just eval, pass in the st. We're gonna save it, buffer.
Go back because I think there's something.
Comma? No.
No, there should be a comma there. Oh, on their and on the error, on the second error, on the first error. Sorry, we need a semicolon there.
No, here.
No.
Second.
Lines. Yes, this
Semicolon or comma?
semicolon. Yeah, it didn't change much. It was already formatted. Okay, now run. Now it's wrong. You remove it.
Yeah, I remove it because they are exactly the same.
Okay, that's why. Yeah, so just keep the just yeah, that.
What are the chances, huh? Huh?
Well, very low. If you want to hear me.
What are the freaking chances? Spoon, main. Come on. Examples.
Yeah, man, it got to a point that I think I would prefer being JavaScript. I know I will repent on these words, but I would prefer to do JavaScript than this. Okay. Yeah, let's be modest. That's a virtue. No, don't try to lobby, Nathan. That's not a
No,
CPU.
oh, you already lost the battle. You said that you prefer JavaScript. You already lost. Nathan will
No,
say
I
that
prefer
forever
JavaScript
now.
to this. Those are on the same level, like the same levels of abstraction there.
I prefer this than JavaScript.
I don't know.
I personally prefer LFA because now I kind of got
Yeah,
the gem.
LFA has a saving grace of being Lisp. That's the only thing. Error.
That's the best
I
error
think
possible.
67 is A, right?
Um,
A
67.
111 is what?
67.
111 is O. So it's oh well wait. 67 is
C.
so could not probably.
Yeah, could not something. The typing is fine, so there needs to be in here. What error message starts with the letter C? This.
Mhm.
Okay. Oh, that's why we had the terrible error message. We need to do
Yes.
Erlang.
Oh, that's so pathetic. Oh, man. So funny. Then the discussion comes: is he sunny or fed? Which one? I prefer sunny. But I think there are more error messages that go with like could not, blah blah blah. Okay, yeah.
No,
Oh,
but this
awesome.
is no someone
Awesome.
else. Someone else is throwing in here.
Oh,
Wait.
remove that string concat. Remove the string concat.
Oh, it's this. I didn't see this. Sorry, I was not paying attention.
Uh, List, right? On the abstraction.
Mm-hmm. Spoon.
I mean, testing this is painful.
Simple. Could not apply the following value
Um,
because it is not a function. That's unexpected. So the
So,
abstraction is a variable.
oh, right. We're stupid. Go back there because we added a type now. So it's native func type function.
Oh, good. Good, Magetta, good.
Yeah, I told you, man. You're handling me as a dog.
Well, maybe with encouragement you're gonna be smiling more.
No. Oh, it works. Okay, done. Commit this,
No, no,
please.
no, no,
No,
no, no, no. There's no
no,
way.
please.
There's no
It's
way.
working. Dude, no, you don't understand me. Commit. It's working. Please, commit.
Okay, I will commit. uh, nothing staged. Oh.
Oh, yeah, it's all unstaged.
Uh, okay. Fixed.
Oh,
Evaluate.
man, I faced your pain. I tried using Magit on Windows. It's so slow.
It's very bad. There is some like hacking that you can do to make it a tiny bit faster.
I mean, it's just... It's better to just drop Windows at that point.
Okay, I want to make a more complicated example now.
Oh, no.
Uh, Actually, this
There's another
is
thing, right? We should unpack the stuff of the AST. We should like print a print method or something. Like a printable, whatever. And if it's a literal, we just print the literal.
no. XK.
We should
Yes.
have a printing function as well. We don't have that. I think I'm gonna try to make today the thing in Elisp just for fun.
Okay, so these are the parameters, these are the body, and these are the things. So we're gonna have an if here. If, I don't know, or false, false, false,
It's
true.
Like the Erlang messages, right?
Um, this needs to be an integer, so
Oh,
let's
we
do
do stamp
plus.
that. Oh yeah.
Uh, I don't know.
Minus.
Yeah, minus.
Do we have
Minus.
negative numbers? We do, right? If it's just interpreted,
I
we
have
don't
no
care.
idea at all. It's gonna be a good test. Uh,
Yeah, I think we do. I don't think we're parsing negative numbers. What? If okay. Okay, that's a good test. Do a division.
uh,
Oh, but we don't have fractions, do
we
we?
don't have fractions. That's a good
So
point.
what is it gonna spit?
Do we
Just
have in the prelude though?
I probably it would be funny if it spits like integer and then it's like 0.5 like oh,
Oh no. Okay, let's try not to do that then. So I don't know. Can be a plus here. Mm, yeah. No. Okay. No. Something is wrong.
yeah, just a plus, just a
Something is
plus.
wrong. Wait. I think there is something like that. Yeah. Okay.
But just spit the plus, just the plus.
No, but that should not type check.
because the plus with nothing is 0. Because remember the fold?
Ah, that's.
Oh, but that's a thing that I think we did wrong then. Because
Let's make some happy
yeah,
scenarios
yeah, yeah.
first.
And then just change the 4 to true.
Yeah.
Theory.
True.
Yeah.
What are the chances, folks?
Very low.
Yay! It's not working at all.
Wait. Types.
Type check.
Types match permitted abstraction. Variable or. What? Or?
Okay, I'm. Maybe the prelude of or is wrong.
Yeah.
Logical
Or is a
functions.
logical
Oh, I
function
see.
of organic boolean A.
Boolean rest.
Oh, it's just boolean rest, yes. We're catching bugs. Some of them. Some of them I never fetch.
uh,
That's right.
that is right.
Yes.
7,
That would
9,
be
10 times 2, 20! I can't believe it!
okay. Now we just need to do a printable. Like just do a print thing. Oh, we don't have unit type, right?
Yeah, we don't have stuff like that.
Yeah, okay, that's trash. Yeah, okay, value.
This shouldn't be. The other one should be impossible though.
Just do a like literal, and if it's like a literal, you just print the literal inside.
No, no, no. I want this to be anything. So, like,
Yeah, yeah,
if
but I was saying like you do it by branches, right? Like, and then you can form it like abstractions, all the rest.
no, no. Let's just
Like,
print like this for now. I just want to get
yeah,
rid of the OK at the moment. Uh, Erlang error.
you are retarded.
Uh, should be impossible.
Should be impossible. It's it's very possible.
No, this should be impossible because if you have an error during evaluation, we throw an exception.
No,
The
that's not
only
impossible.
way to case to do a pattern matching if you have an OK. If you get this should be impossible.
No, what he's saying is okay. I get it.
Syntax error before stuff. I'm doing something wrong. I'm doing something wrong.
And you forgot the end,
Oh, good catch.
and then semicolon,
Semicolon.
and then remove the semicolon from the other. Actually, that's wrong. No, 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 that's wrong. Semicolon there. I learned that crap. Okay, remove the semicolon there, and then add a semicolon on this Erlang error.
Are you sure?
No? Yeah, it should be like that. No, there's no comma there. Comma is to bind new parameters. Remove the semicolon on the yes. Okay, you don't need that.
Erlang
No,
expert, man. That's my get.
no, thank you. I want to forget. I want to erase this language from my head.
Nice. Okay, now it's time.
Just activate the silverware mode, please.
This is
Activate the
already
silverware mode. No, no. Just go to the editor folder
again,
there.
but I already did that.
No, but it's not. Oh, it's with the spoon there. I see. Oh, yes, it is. Sorry. Oh, looks like the colors look so cute, man. Do a Fibonacci.
No,
Can we do a
Fibonacci needs recursion. This is not your incomplete language.
Yeah, we don't have. Oh, it's not available in the same scope, right?
We don't have recursion.
No, we do.
No, we don't.
We do. It's just not the function is just not available in the same scope, but you can have recursion.
No, we need a label to call that, to call it again.
Yeah,
And we don't have
that we
that
don't
that
have.
capability here.
Yes, that we don't have. But you have the. We. Oh, it's not hard to do.
Uh, um,
It's not hard, man. You just allow this very definition to be inside the body, inside the map as well. A closed environment, I guess. In this case.
Yeah, we don't. It's not hard, but it's not as easy as.
No, I don't understand how you can have recursion if you cannot name something.
Oh,
Well,
we don't have a let.
you
That's so.
can, as you saw already. I'm pretty sure.
No, we didn't. I never saw in
No,
Silverware that.
lambda
No,
calc.
like
Oh,
you're
lambda
talking about the
calculus, okay.
omega.
Oh,
So
they'll.
yeah, you don't need names. But the thing is, since we have typing, we cannot have recursion. Like it's strongly normalizing, right? So it would need the let rec node.
Hmm.
Oh, I see. Okay, so the idea was to use the Y combinator, but we don't have that because, well, reasons. Uh,
That's a proof to you that types are just useless, man.
Yes, it's the same, man. We should have just dropped them.
Wait a second.
I think this will break. I really think
Man,
so.
wait. I think I found a fundamental flaw in this. It's gonna be really funny if that's the case. I hope I'm wrong.
Either you are wrong or right. I'll just give up right now.
The fundamental flaw in which part, to be more precise? The grammar?
Everywhere.
No, the grammar is right.
Well, we think it's right, but
Yeah, we think it's right. Because isn't the abstraction supposed to have a return type with some columns, something like that?
some what? Column?
Yeah. Shouldn't this have a
It
return type?
doesn't. It it has
Where?
after the list of argument types.
No, we don't have. This works.
Wait, just a second. Let me just
While you
finish
guys
some stuff here.
discuss, let me read the CG date.
Okay. Okay, let me see. Lambda, those are the types. Indeed, it should have.
Yeah, so this works. How does this work?
Oh, no, 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 wait. Uh, oh, no, okay, yeah, this is right. This is right. So, see, uh, yeah, like basically you only need in a function to annotate the parameter types. The only case where you would write the arrow type is if you are receiving a function as
Oh,
argument.
the lambda doesn't have is only the arrow.
Uh, it's like you have types, right? You have the atomic types like integer and boolean that you are describing the parameters there. But try to receive a lambda now.
No, but
See, you
no, but
will.
no, wait just a second. The arrow, because I think I'm making the same confusion I was making on Tuesday. There is a difference between the abstraction and the arrow. Both are function related, but they are completely different. So the abstraction you don't have to specify the return type, but the arrow you need to.
Yeah, you are kind of right, but kind of using the wrong way to think about it. So we have the abstraction, right? What is the abstraction? It's an expression, it's a term, but we have a type for that. The type of that expression, it's the arrow type. It describes its parameters and its return type. We don't annotate the return type during an abstraction because we don't need to.
Oh, okay. So I was freaking out for no reason. Nice.
So when we have like parameters and you want to receive a lambda, then you need to like describe the arrow type, right?
Yeah, but where is this? Oh, here. This is the return type. Okay. Okay. I'm confident now. Let's go. So this is a function. This is a function that receives two integers. And these should be another parenthesis, by the way. And then it will return another integer. Args type left delimiter. Yeah, that's it. Okay, and we're also gonna have a variadic part, which I'm gonna call just numbers, and this is also an integer. So if this is false, if that's false,
Lemos, that's interesting. What do you think about those things? Like, you are receiving a function that has like 2 parameters. They are integers, right? Would you accept a function that is like variadic with numbers?
Oh,
Wait, no,
no,
doesn't make sense,
no,
doesn't
that
it?
does make sense. You mean like this,
Yeah.
right?
Yeah, because it could be like not having the last one. Okay, that doesn't make sense. But what about one that has at least 2 and then it's variadic? Then it
No,
would
that
always
doesn't.
like
Yeah,
match.
that does then. Yeah, I see what you mean. Anyway, so these are the arguments. Now let's make the body of this madness. The body will be an if again, and if it's a boolean, we need to apply z to the first. Yeah, we want to apply z x with 2. I don't know if this is the way that we should do that. And if it's false, we're gonna pick these. What do you think, Nathan?
I'm not looking at it. What do you want?
That doesn't care, man.
This is
Nobody
an
care.
integer. This is the integer, and this is controlling the thing there. This.
Uh, oh man, the brackets are confusing. Um, what is that bracket that you have before the first if?
Sorry.
What is the bracket that you have before the first if?
Before the first, this is the type
No,
annotation for
no, no,
the
no.
lambda.
Before the first if, like in the if.
Oh, this is the
Yeah.
the the then.
The then?
Yeah, because the z is a function. I don't know if this is the way that we settle on.
The then? No, wait.
This is a boolean, okay?
Man, like you see the left bracket that is blue in that line?
Mm.
Is that the body of the function?
Yeah, this is the body of the lambda.
Okay, so then the red one, it's like closing the lambda,
Yeah.
and you have a white one that is not being closed as far as I can
Yeah, because
see.
this is an application.
That is the application. Okay, okay.
So
And then you are applying that an on an if, right?
yeah, because the if will reduce to an integer,
Oh, okay,
which is the
okay.
first thing here.
Oh, I see, I
And
see.
then we have a boolean, which is this true here.
Mm-hmm.
And now I want to make z.
Oh, okay.
I
Yeah,
don't
but
know
we
if
are
this is the way.
just. Uh,
And then the last one should be a list, right? So we're gonna have like that, and then 1, 2, 3, 4, 5.
1 plus 1.
Wait.
Oh, that's a really nice way to test. You're like using a bunch of shit.
Yeah.
Numbers. No, but wait. The numbers.
And this is wrong.
Okay, I
Now it's
see. Yeah,
correct.
that's fine. But that shouldn't be a list, right? That should be just 1, 2, 3, 4, 5.
Oh yeah, that makes sense. Sorry, it's a list just in the sense of the implementation of the thing.
Yeah, that will certainly break.
I like your confidence, Magetta. What do you
No?
think, Nathan? What are the chances?
Man, it looks good syntactic wise, but I also think it's probably going to break.
Okay, so let's try to guess the result here. So it is true, which means that we're gonna only care about this,
Yes.
and then this is a plus of the two numbers, so it's gonna be 1 minus 2 minus 3 minus 4 plus 2. So it's 1 minus 3 minus 4, which is minus 6, I guess. Does that make sense?
Well, yeah.
Well, yeah. Oh man, I am nervous.
Really?
You know it's gonna break, man. I told you.
Yeah, totally broken.
Oh, wait. Oh, it actually did.
Yeah, of course.
Wait, everything is inside the condition.
Is it because of
Mm,
the plus?
Type check variable, not
The,
function clause matching.
but look, like
Oh,
everything is
I know,
inside
I
the
know.
condition. Oh no, it's the array.
How? Oh, fuck.
What?
This
How
is
much?
not this.
Hmm?
Yeah, how can? Uh, yeah,
Oh,
is
this
this
should be.
this? Is this this?
It is.
It is.
Yeah.
Should be.
No, or better, it should be, yeah.
Okay, so let's pick this entire thing.
But he just said, right? The clauses are wrong somewhere in the mesh. Like, why would you check that statically if you can, like, find out eventually, right?
No, man. Totally terrible, this view.
Well, that's what you are fucking using, man.
No, no, no. It's because for some random reason it's not like this is better than that. Let's try to read this, by the way. So it is a variadic function, which is correct. Then we have the x, which is an integer, and y, which is a boolean. Then we have a function, which is the z, which picks two integers, and that function is not variadic and returns a new integer. Then we have the variadic part, which is this, right? Then we have a bunch of conditions. My guess is that the problem is with z. That's my guess. So how do I copy this crap? I think it's YF. YF. Arrow. Yeah. Let's do the following. Let's eliminate some variables here. We want the simplest of the simplest, which is this. Then we just want zx2. And probably we have extra parentheses at some point. Yeah. Okay, so this is the body. Kill all of these. Mm. What do you think, Nathan?
I'm not looking at it yet. So,
This is the simplest way to test if the arrow is working.
oh, you're testing on there, right?
Yeah.
Uh, Shift Z. Uh, yeah. It looks right to me.
Okay.
That doesn't say anything.
Yeah, that doesn't say
Like, only looking at the thing.
3.
It probably can parse it,
3,
but
Wait,
okay.
it
which is
worked?
correct. Okay, so the
Now,
arrow
if
is
the
not the problem.
arithmetic was wrong,
No, but that means that the z is not the problem. So what exactly is the problem
No,
then?
what the
probably the
condition?
rest.
Check
Probably
the
the
condition.
rest.
Is
Yeah,
it even right, the notation for rest?
Yeah, it is. This is how the parser is expecting it.
Mm.
Let's do the rest then. The minimum amount of effort to test the rest.
Oh yeah, you just tested the plus, right? So that's also the thing.
but okay.
Um.
And
Okay,
that could be
I'm
just
not.
just some, just some.
Yeah, that's it, right?
Well, you could just sum them. No, we don't have a list.
We don't
So
have the
what is
list
the type?
representation. I think that's why it didn't work in the advanced one.
So
Advanced.
Yeah,
advanced,
the advanced example.
a high order
Still
function,
wrong.
advanced.
Well,
Sum
for
the
some
numbers.
folks, that's from out of this world, Maget.
Sum the numbers, man.
No, this should print 2, 3, 4, 5, right?
No, we don't
No.
have we don't have a concept of a list.
So only plus in with these.
Yes.
Still wrong. Am I saving? Yeah. Am I running the rest? Yeah. Yeah, so the
Mm,
problem is the variadic part of the thing.
cringe.
I don't remember testing that though.
But
Did we
that's
test
easy
that?
to solve, man. You just pretended we don't have varied things.
Oh, uh, at some point Nathan
Anyway,
decides to go to Magueta's partido, man.
no, man,
That's sad.
Nata is my buddy.
No, no, I'm just being ironic.
I'll just have dinner. I'll be back.
1, 2, 3, 1, 2, 3. Not. I think we didn't test that. That's why we didn't discover earlier.
Best.
Yeah, so let's go to the. I think that the typing is correct though. So let's go to the eval. I think it's in here. It is the eval
Uh,
closure
hey,
variadic.
can you show me how you were using the argument from the rest?
What do you mean?
Uh, you were receiving a variadic parameter. So how were you using that? Do you remember?
We pattern match in the eval closure.
No, 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 no. The program that you wrote.
Oh, here. What do you want to know?
Yeah, how were you? Oh, you were using like plus and numbers that is variadic, right?
Yeah,
Yeah, that would never work.
that's what I'm
Yeah.
talking about. I think we need the list representation in the language to not
I
make
think
this
I
work.
said that a bunch.
You said this in the beginning, yeah. You definitely said that in the beginning. So, uh, but then I'm confused. What exactly is being printed in the thing? Like, what is happening inside the environment? Are we putting number? How is numbers being put in the environment?
Ah,
Because as far as I can tell, I do believe that they. Uh,
and I probably think they are being just like an int instead of
a
list of
list.
an int.
That makes sense.
But yeah, we don't have the type list as far as I know, right?
Uh, we don't have the type list, yeah. But I want to check how exactly this is being done to see if this is easy to fix or not. Uh, so AST. What is the AST of my program? Spoon. It is complaining. It is complaining that this is comma.
Hmm. Something that you could do is basically do a function
Here it
that
is.
receives. Wait, what is that?
This is the AST of that.
Okay, integer numbers.
Yeah, we could just grab this one and put everything mapped to like this. We don't need a list representation in the in Silverware. We just need to use the list representation of Erlang. We just need to map this to all of those.
Uh, wait. Can you repeat?
Yeah. So what we need to do is map x to 1 and map all of those in a list to numbers in the environment.
Yeah, we do that.
I don't know if we do that.
I would think we do in the eval, but that's not the only thing we have to do, Amos. That's only for the eval, and well, that's
This
like
is the
obvious.
evaluated values, I guess. So these are would be the numbers. Then we see if we found an error. Oh, this is why we were doing that
Amos, but
that
take
thing
a look, man.
there.
If you are receiving the X, it needs to have the type list inside the thing, because otherwise you would not be able to check. So, for instance, if I'm receiving numbers and then I'm applying a function passing numbers, then the type of this function needs to be like list of int. So it needs to even be in the parser, the list thing.
I don't think so.
I don't think you have a way to.
That's what I'm looking at.
Um,
So do we have format LSP format
let me
buffer?
see.
No formatting
Oh,
provide.
yeah, sure. You could avoid that, but basically what you would do is, okay, you cannot make functions that receive lists. And then you would only provide like the standard ones from the library.
Yeah, that's what that's kind of what I want to do.
Yeah. You would still need the type list to put in the environment for those native functions.
Uh, 1 second, please. 1 second, please. Okay, so now let's try to. Okay, no formatting changes provided. That's cool. Is this working? Oh, this is not working. I see. So, does this have... Okay, this have a semicolon. Okay, now formatting should work fine. Applying 2 edits to... Done. Okay. Okay, so... We know it is variadic. We have the arguments and we have the labels. We know how to get the non-variadic parts of it from both of them. We have the name and we have the args. We just need to go to the environment and map this name to the remaining part of this list, and then you're done. As far as I can tell, it is exactly what we do, by the way. Okay, so we add to the non-variadic names with map zipping with the non-variadic args. So we are mapping the x with the 1. Then we pick the variadic name. We map to the remaining args, which makes sense. Then we merge the 2 environments. So I think that printing this guy will be very useful. Nathan, are you there?
Yeah.
Okay. We are not even getting there. We are not even getting there, which is not cool at all. It's time to type check a variable. Why is it doing that? Line 65. 65? 65 is in here, so it's definitely not the same crap. Oh, it is in the type checking. Okay. Now I think I got what you mean about having the list type. 65. 65. Type check variable. It's not pattern matching. Why? Why is it not pattern matching? Okay, we need to uncomment this guy. Oh no. Still wrong, comma. Still wrong. Tough. Okay. Because the previous clause, okay, it will always match. Okay, I'm fine with that. Okay, so what is this thing printing? Okay, so this is the environment. Oh, and this is the variable that is trying to pattern match. This is being classified as a variable. Why? Very, very weird indeed. Very weird. How is this a variable, man? How is this a variable? Holy crap. Could not type check. this doesn't make sense. This doesn't make sense at all. We are recording now.
What?
I restarted the recording because I just wanted the archive to know that
Oh, but we
the
were not recording.
entire problem was because the parser was wrong, and then we went back, fixed the parser, and now after some debugging that we did in off, now it's working. And
I'm glad I asked if you.
Yeah.
yeah, so future us, now you know.